Hi there, Mr. Boer here with Physics Week 4 online learning. And what we're going to look at is kind of some new stuff here with circular motion, which is going to end up being parts of chapter 9 and 11 if you have your book. I know it says 10 and 12 on this one, but the new version, just the number of chapters are off a little bit. So in the first one, we'll look at some circular motion. We'll look at a more mechanical or rotational mechanics after. First thing, kind of abbreviated these PowerPoints down into what I think we need to know. The difference between rotation and revolution. Rotation is spinning about an internal axis, while revolution goes around an outside axis. And we can easily think of rotation as being how the Earth rotates 24 hours in a day as it just spins on its own. And then it revolves around the sun 365 days in a year. 365 and a quarter. Let me get that. Don't forget that quarter. It does make a difference in that leap year, but that's the main difference between rotation and revolution is where the axis is. Now, in doing so, we talk about two different types of speeds. In rotational speed, we're talking about how fast it revolves about the axis. So in those two types of speed, one of those is what we already learned in chapters 2 and 3. Those were linear speeds. Even if it's moving in a circle, and if it was to stop moving in a circle, such as I got a tin can attached to a string and I'm whirling it around my head, as soon as I let go, I then lose the force that we're going to talk about in a second. It's going to move off and have a tangential speed. It's going to move off in a tangent to the circle, which is going to be a straight line. So linear speed and tangential speed are the same thing. It's just depending on whether it has been in a circular motion to begin with and then it stopped, or if it was continually going in a straight line. Which then brings us to the second type. Second type is its rotational speeds. How many rotations per unit time? So how many rotations is it making? That is sometimes called its angular speed too. So just like linear speed has tangential speed that mean the same thing, rotational and angular speed also mean the same thing. If you look at RPMs on your car, that's revolutions per minute, RPMs. It's the same thing. It's not counting the linear distance. It's how many rotations you're taking, and that's what rotational speed is. So all parts of something moving in a circle are going to have the same rotational speed. So if you look at the ladybug here, as we look at, it's going to be moving here as it goes around. It's also going to be moving around in this spot. Now, what the difference is, they're going to have the same rotational speed because whatever time it takes that to go around is going to take the same amount of time for that ladybug to go around. So they have the same rotational speed, but they don't have the same linear speeds. Because if we just take the actual distance that it's traveling going around on the outside of the turntable or the record here, it's going a greater distance in the same amount of time. And if you go more distance in the same amount of time, you're actually going faster. So this ladybug or a person sitting on the outside of a merry-go-round is actually going faster linear speed, yet they have the same rotational speed. Now, what do we need? There's a force acting on it because there's an acceleration. Now, why is there an acceleration? You can speed up, you can slow down, or you can change direction. And if you're moving in a circle, you are continually changing your direction. So even if your speed is not necessarily changing, your rotation or linear speed, you are still accelerating because you're changing a direction. And if it's making you go in a circle, we call that a centripetal acceleration. Well, if you remember from chapter 4, there must be a force acting on it in order for it to accelerate. 4 and 5, we talked about Newton's laws. So there must be a centripetal force causing it to move in a circular direction. So that's all a force is causing an acceleration. But in this case, it's making it go in a circle. That's the only difference. So a lot of the same things we talked about in earlier chapters, we're just now kind of changing it to be a circular motion. Centripetal forces. If we want to know the direction of the force, all centripetal forces are towards the center. They're always inward, never outward. We'll talk about that in just a minute in segment 2 as we get going, that there is a centripetal force and what is a perceived centrifugal force.